Mars, the enigmatic red planet, has captivated human imagination for millennia. Its rusty hue, a beacon in the night sky, has long inspired tales of alien civilizations and cosmic wonders. Today, as our robotic emissaries traverse its dusty plains and scrutinize its thin atmosphere, the allure of Mars has only intensified. We stand on the precipice of potentially monumental discoveries, driven by an insatiable curiosity to uncover the truths hidden beneath its ruddy veil. The modern era of space exploration has transformed Mars from a distant point of light into a tangible world, a landscape of towering volcanoes, vast canyons, and ancient riverbeds. Each new mission, each packet of data beamed back to Earth, adds another piece to an ever-expanding puzzle. The possibility of past or even present life on Mars is a central theme in our quest. The red planet serves as a cosmic mirror, reflecting our hopes, our fears, and our relentless drive to push the boundaries of knowledge. The coming years promise even more sophisticated missions and analytical tools, bringing us ever closer to potentially unveiling the hidden truths of Mars. The year 2024 has been particularly revelatory, with a cascade of discoveries painting a picture of a Mars far more dynamic and resource-rich than previously imagined, especially beneath its surface. Scientists analyzing data from NASA's InSight lander reported the astonishing discovery of a massive underground water reservoir. Such a vast body of liquid water immediately ignites speculation about potential habitats for microbial life, shielded from the harsh surface radiation. Further adding to this narrative, researchers announced the discovery of enormous chunks of ice buried up to 2.3 miles beneath the Martian equator, within the Medusae Fossae formation. The strategic implications for future human colonization are immense, but they also raise questions about whether others might have already recognized and utilized these equatorial water sources. The revelations continued with the identification of a giant, heavily eroded and long-dead volcano in the Tharsis volcanic province, harboring a sheet of buried glacier ice near its base. No discussion of hidden Martian truths would be complete without revisiting the face on Mars, an iconic anomaly that ignited public imagination and fierce debate for decades. Captured in 1976 by NASA's Viking 1 spacecraft in the Cydonia region, the image appeared to show a colossal humanoid face staring skyward from the Martian plains. For many, this was not a mere trick of light and shadow, but a deliberate monument, a message from a long-lost Martian civilization. NASA's official stance is that the face on Mars is a natural geological formation, a mesa, common in the Cydonia region, whose facial characteristics were an illusion created by the angle of sunlight and the low resolution of the Viking camera. Subsequent missions provided much higher resolution images, showing a heavily eroded rocky outcrop that bore less resemblance to a human face. For the scientific mainstream, this seemingly closed the case, relegating the face to a fascinating example of pareidolia, the human tendency to see familiar patterns in random stimuli. The legacy of the face on Mars continues to influence how we perceive Martian anomalies, serving as a reminder of the powerful allure of the unknown. The quest to uncover Mars's hidden secrets is increasingly reliant on sophisticated technologies capable of peering beneath its dusty surface and deciphering its complex geology. Among these, advanced radar systems stand out as particularly promising tools. The recent rediscovery of Camp Century, a Cold War-era U.S. military base buried deep beneath Greenland's ice sheet, serves as a powerful terrestrial analog. This feat, accomplished in April 2024, utilized NASA's UAVSAR, or Uninhabited Aerial Vehicle Synthetic Aperture Radar. Adapting UAVSAR-like systems for Martian orbiters or even rovers could revolutionize our ability to map the Martian subsurface, potentially revealing lava tubes, buried water ice, or, more speculatively, artificial cavities and constructions that have eluded surface-level observation. Interpreting radar data, however, is not without its challenges. Distinguishing between natural geological formations and potential artificial structures would require careful analysis, cross-referencing with other datasets, and perhaps even ground-truthing by future robotic or human missions. Despite these challenges, the ongoing advancements in remote sensing technology offer unprecedented hope for uncovering what lies hidden. Each new instrument and analytical method sharpens our vision, allowing us to probe deeper and with greater precision. The idea of secret bases on Mars gains a certain plausibility when we consider humanity's own penchant for constructing clandestine facilities here on Earth. The aforementioned Camp Century in Greenland is a prime example, a sprawling nuclear-powered city beneath the ice, designed for military research and operations, its existence largely forgotten until its recent rediscovery. If humans could build such a sophisticated complex in a remote and hostile polar environment in the mid-20th century, it stands to reason that a technologically advanced civilization, whether native to Mars or visiting from elsewhere, could achieve similar or even greater feats of subterranean engineering on the Red Planet. The motivations for establishing hidden bases, whether on Earth or Mars, often revolve around secrecy, security, and access to resources. On Mars, the harsh surface conditions would make subsurface locations highly advantageous. Underground bases would offer natural shielding, more stable temperatures, and potentially easier access to subsurface water ice or geothermal energy. Comparing Earth's hidden bases to potential Martian equivalents also involves considering the technological leap required. The critical question when examining any unusual Martian feature is whether it owes its existence to intelligent design or to the blind, albeit often spectacular forces of nature. Mars is sculpted by volcanism, wind erosion, ancient water flows, and tectonic activity. These processes create formations that can appear uncannily artificial. The spiders on Mars, near the Inca City Formation, are striking features. Scientific consensus attributes them to the seasonal sublimation of carbon dioxide ice. The face on Mars, once hailed as proof of alien sculptors, is a mesa shaped by erosion. Nature produces geometric regularity that triggers our pattern recognition faculties. A high bar must be set for claiming artificiality, requiring robust evidence. The challenge lies in developing clear criteria for distinguishing the truly artificial from the merely anomalous. The potential discovery of secret bases on Mars, whether ancient ruins or actively maintained facilities, would carry implications so profound they would ripple through every aspect of human society. Scientifically, it would be a watershed moment, instantly transforming our understanding of life's prevalence in the universe and the potential for technological civilizations to arise on other worlds. The nature of such bases, their design, materials, energy sources, and any artifacts within, would offer an unparalleled window into alien biology, technology, culture, and history. From an exploration perspective, finding pre-existing structures, particularly subsurface ones, could dramatically alter plans for human colonization. Imagine discovering stable, shielded lava tubes already adapted for habitation, or even remnants of advanced infrastructure that could be repurposed. This could fast-track human presence on Mars, providing solutions to challenges like radiation shielding and habitat construction. The philosophical and societal impact would be equally transformative, potentially inspiring a new era of global unity as we collectively grapple with the knowledge that we are not alone. Mars continues to beckon, and as we listen more intently to its whispers, we may find ourselves on the threshold of a discovery that redefines not just the Red Planet, but ourselves as well.